Hey folks, welcome to Mtel 0019. So in this section we're going to try to cover understanding operations on numbers, which is an extremely vague title. We're basically going to try to look at some computational algorithms and understanding the meaning of some operations on the numbers. I think so. We're going to focus probably more on the operations that are probably less familiar to most people, so not addition, subtraction, multiplication, and stuff like that. So probably the slightly more complicated ones. And side note, this is my second time making the video because, of course, when I go home to my house to put this online, being the genius I am, I canceled something and I had never saved it. So welcome back. This is the second time I've been talking to you, but let's get going. No holding grudges. All right. So the first operation I want to talk to you guys about is exponentials. And so just like how multiplication was repeated addition, exponentials are essentially repeated multiplication. Okay? So it's like we are multiplying by the same thing over and over again. So a nice example of this would be the term 7 cubed, which is basically means that it's 7 times 7 times 7. Well, maybe we should actually do a 7 here. So 7 times 7 times 7. Okay? And perhaps if we had written an equation, like y equals 5 to the x, and made kind of an xy table out of this, we could see that 5 to the first power is 5. 5 to the second power is 5 times 5, which is 25. And 5 to the third power is 5 times 5 times 5, which is 125. Okay? Now, a pattern you can kind of see is that as you multiply, or as you proceed down this list, you are continually multiplying by 5 more. Okay? And so it stands to reason that working back the other way, you are dividing by 5. So dividing by 5, dividing by 5. So it would be, I think, fair for us to assume that that pattern will continue, in which case 5 to the 0 power is 1. And that's actually a very special case. We're actually labeled that as kind of our first important exponential property, which is that anything, so I'm just going to put a, to the 0 power is 1. So literally anything to the 0 power is 1. And by being a math teacher, by literally everything, I of course mean not everything. This doesn't work with 0. Like 0 to the 0 power doesn't exist. But I promise, anything else to the 0 power is 1. Now, let's continue this pattern more. Why would it stop there? It doesn't. So, if I would go backwards one more, this is saying that 5 to the negative first power should be 1 divided by 5, which is odd. And which means 5 to the negative second power should be 1 divided by 25. And the reason for this is kind of our second exponential property, which has to do with negative exponents. And that is that something to a negative exponent really just wants the reciprocal of that. So that's really 1 over a. Okay? So, for example, an example of this, if I wanted 3 to the negative fourth power, that is the equivalent of 1/3 to the fourth power. Or maybe 2/7 to the negative second power is the equivalent of 7/2 raised to the second power. So anytime you see negative exponents, do not be afraid of them. You are just taking the reciprocal. You're looking for the kind of putting it in the denominator, usually. Now, the next property I want to talk about has to do with combining, so like multiplying things. So if I'm going to pick two different letters for my exponents. We're going to a to the m, and we're going to multiply that by the same number a, but to a different exponent. We'll see, what does that mean? So looking at an example, let's see what's going to happen. Let's say we have 2 to the 5th, okay, times 2 to the 3rd. And so what that means, if you recall, 2 to the 5th means we have 2 times 2 times 2 times 2 times 2. It's that I have 5 2's, and then 2 cubed is 2 times 2 times 2. It's having 3 2's, which means altogether, how many of them do I have? This altogether is 2 to the 8th. So what you can see, well, how do I get 8 from these two numbers that were given me, the 5 and the 3? Well, it's just addition. Okay, so you're just adding the exponent. So this is going to be equal to a to the m plus n power. Okay. The next one is really kind of the same thing. I don't think it really requires, it maybe shouldn't require its own. And that is, what if you had a to the m divided by a to the n? Okay? I'll show you very quickly two different ways of doing this. One, we'll take kind of the same example. We'll do this one in blue, where if I had 2 to the 5th over 2 cubed, again, 2 to the 5th is 1, 2, 3, 4, 5 2's, and 2 cubed is 1, 2, 3 2's. And so I think when you look at it that way, it's pretty clear to see that these will reduce, these will reduce, these will reduce, and I'm left only with 2 2's in the numerator. And you say, well, how could I come up with that number 2? Well, I had 5, I had 3, I divided 3 away, and this becomes a subtraction. Now I say I didn't need to really show you that, and this is why. If I had a to the m over a to the n, if you recall what we had just done, negative exponents, you want the reciprocal, so you want the things in the denominator. Which means if I had an a to the n in the denominator, that's the same thing as a to the negative n in the numerator. Okay, so feel free to kind of double check that or go back and check where we were just talking about it. And if you look at our previous rule up here, what do I do when I'm multiplying? I add the exponent. So I'm adding the m with the negative n, and that becomes m minus n. So we get the same thing, and there's two different ways of really looking at it. Okay. Now the very last one is, what if I had a to the m, and then I had that to another exponent? And then you'll say, well, that's kind of crazy. So then what do I do with that? Well, let's take the example. Let's do 3 squared, and we'll have that raised to the 4th power. Okay? So just ignoring the fact that this is a 3 squared, what does it mean to raise something to the 4th power? Well, that means to multiply it by itself 4 times. So it doesn't matter if that's a 7 to the 4th power, a 2 to the 4th power, or in this case, a 3 squared to the 4th power. So it's going to be 3 squared a total of 4 times. Okay? Now at this step, we can go back at another property that we'd seen. What do I do when I am multiplying exponential terms that all have the same base? They're all base 3. They all have this base 3. What do I do with their exponents? Well, I add them. So this comes to 3, and then I have 2, 4, 6, 8. 3 to the 8th. Okay? And as you see, how do we get to 8 from 3 squared to the 4th power? We are multiplying the exponents. Okay? Now I think a good one for you to try, real quick, would be to very quickly simplify 7 cubed over 7 to the 8th. Okay? And see how we can do from there. Alright, so we're going to talk real quick about order of operations. Hopefully not going to spend too much time on it, because hopefully everybody's pretty familiar with the term PEMDAS. So that stands for parentheses, exponential, multiplication, division, addition, and subtraction. And so that is the general order in which things are done. It's like the hierarchy of arithmetic. And the one thing that I really wanted to point out, because I'm sure people can just follow an order like this, but it's that multiplication and division are on the same kind of playing field. They're like the same level of importance. Addition and subtraction, same thing. They're on the same level of importance. I feel the need to say that because I was in a class when I was becoming a teacher, getting licensed, and there was a middle school teacher who gave us a 20-minute sample lesson on the order of operations where she was adamant that multiplication must be done before division because it comes first in the word PEMDAS. And it was one of the most awkward things I had to sit through. So please do not do that. Keep in mind that multiplication and division are really kind of the same thing. What I mean by that is that if you were, just as a quick side note, if I took something, say like 6, and you wanted to divide it by 2, that's really the same thing. I'm going to try out this fancy arrow button. Oh, wow, what a horrible use of the arrow button. That's really the same thing as continued horrible use of the arrow button. You know, we're not gonna use that. We're not gonna use that. That's really the same thing as 6 times 1/2. Okay, so these two things, the idea of dividing by 2 and the idea of multiplying by 1/2, are completely equivalent. So the idea that one of these would have precedent over the other really doesn't make any sense. So keep them going in this order, but keep in mind that multiplication, division, addition, subtraction are really, they're on the same playing field as each other. So those are interchangeable. What I want to mention is the difference between evaluating and solving. When you're evaluating, you're really just kind of simplifying using order of operations. And it is something that has, as a main defining feature, is that there is no equal sign. You don't evaluate an equation. You can evaluate at a point a certain part of an equation, like a side of an equation. But evaluating the term is done only with expressions, and expressions are things without equal signs. Whereas solving, you are dealing with equations. And obviously, because you see the word equations, it has an equal sign. Evaluating is only with expressions. And I just want to give you kind of 2 quick examples on those. Alright, so let's look at an expression. Let me just scribble the crap out of that. And so we're looking at maybe this expression 2 times 3 squared minus 5. So if I wanted to kind of simplify this expression, I'm basically just kind of evaluating it. I'm just turning this all into a single number. Like, this will collapse perfectly fine. Notice that there's no such thing as, like, you're not solving for anything. Solving is reserved purely for finding the value of a variable. We have no variables, so there's nothing to solve for. So I'm just going to perform order of operations. So I need to do my exponents first. So this is going to be 3 squared is 9. Then we're going to do some multiplication. So we're going to have 18 minus 5. And that's going to leave us with the number 13. Now an equation, okay? An equation is something that we can actually solve. So that means we're going to look for a equal sign. So if I had 2/3 x minus 9 equals 80, I can solve that for x. Meaning I can look for a value of x that makes this whole statement, this whole equation, true. Okay? And so when I'm solving, I'm working backwards to a large extent. So what that means is, compared to this, where I was doing exponential, where I did exponentials first, then I multiplied, then I subtracted. Since I'm undoing it, it's like peeling back the layers of an onion. I don't start with multiplication. I start at the very end. So, like, as you can see at the very end here, I ended with subtraction. At this point, that's the first thing I have to undo. So in this case, I'm going to add 9 to both sides, and that is going to give me 2/3 x equals 89. And then I have to undo this multiplication. So in this case, it's going to deal with me multiplying by the reciprocal, which is 3/2. Okay? And so, I don't know why I did this to myself. So the 2's are going to reduce, the 3's are going to reduce. That leaves me only with the x. And 89 times 3 over 2 is going to be 267 halves. So a very beautiful number. But the idea is that when you are solving an equation, you're undoing everything. So you're working backwards. It's almost like the opposite of PEMDAS. When you are evaluating an expression, you're going forward. So you're definitely using PEMDAS. And so something like this is like something that shows up on Facebook all the time. People always think, hey, I'm going to send this to the high school math teacher because people always get this wrong, and I want to look like a genius here. And so what happens is people it's confusing to some extent because I hate this division symbol. Okay, but if we were to properly, what do people usually get this? I think it's 9. No, wait, what's the wrong answer that everybody gets on this? They get 3, 6. They always get 1. So people always get the answer 1 here because what they do is they add the 3, they multiply, and then they do the dividing. And that's not really what you're doing. So the first thing you do is inside the parentheses. So this becomes 6 divided by 2 times 3. And then these are all on the same playing field because I have division followed by multiplication. So you just work from left to right. So 6 divided by 2 is 3. And then 3 times 3 is 9. So I think this is, the problem with this is the notation. And I really hate this division symbol. I hate it. Once you get to high school, it pretty much entirely disappears. A way that you would write this in high school is it would be 6 divided by 2. And it's that quantity times 1 plus 2. And writing it like that, I feel like not many people would make the same mistake. All right, so after talking about exponents, a different function that I want to talk about is the absolute value function. So that's this function. If you recall, it looks up like this. It's got like bars around your value. And if you ask somebody what the absolute value function does, they'll probably tell you something like this. They'll probably say, well, if you take the absolute value of a negative number, it makes it positive. And if you take the absolute value of a positive number, it stays the same, which is true, and you'll be able to probably successfully do almost all of the math with that understanding of absolute value. But you're going to be a teacher, and if somebody asks you, you want to have a better answer than that. And what I mean by that is you don't want to have kind of that if-then mentality. Like, if it's negative, it does this. If it's positive, it does that. If you have a function, if you come up with a whole operation in mathematics, it better just do something. You better not have to meet special qualifications. And so this is not an exception to that. What the absolute value function does is it represents a number's distance from 0. Okay? And I just quickly jotted that down so you don't have to read my horrible handwriting because I think it's important enough for you to be able to read. So if I drew kind of a number line, we had 0, we had the number 5, we had the number -5. So if you notice, the distance between 0 and 5 is 5. Therefore, the absolute value of 5 is 5. And the distance from -5 to 0 is 5. And that's why the absolute value of -5 is 5. Because distance can never be negative. Distance is always measured positively. So looking at another quick example of something like this would be the absolute value of x minus 5 equals 3. So there's two ways to look at this. The first way is to look at it in terms of this distance idea up here. And so what I would say in this equation is that I'm looking for an x value such that the distance between the x and the 5 is 3. Okay? Which means if I were to draw myself a number line, it means that if I have the number 5, my x is going to be the number that is a distance of 3 away from it. Now, it doesn't matter what direction that distance is, because absolute value is just distance. It doesn't matter if it's distance in the positive or distance in the negative. So in this case, the number that is 3 away from 5 in the positive direction is 8, and the number that's 3 away from 5 in the negative direction is 2. And so I would be able to write those as my two solutions. Now, if that's a peculiar idea, and you want another way, well, you're in luck because there's another way. And I would try to understand both ways, because as an educator, you always want to have several ways of answering a question or explaining something. So if a kid says, that explanation doesn't make sense to me, then you're not immediately out of tricks. You can have kind of a second way. And this is the other way, is that you know that the absolute value of this stuff is 3. So if you recall this kind of like simpler idea, this kind of non-formal definition, that means if this stuff in here was 3, the absolute value of 3 is 3. Or if the stuff that's in here was negative 3, well, that's okay, because the absolute value of that is also 3. So we can kind of create two separate equations from here. We can say, well, that means x minus 5 is either equal to 3, in which case the absolute value of that is 3, or, looks like the r, or x minus 5 is equal to negative 3, in which case the absolute value of that is also 3. And solving for x, I add 5 to both sides, this becomes 8. Solving for x, I add 5 to both sides, this becomes 2. And you'll get your answers either way. Alright, so that seems easy enough, but looking at another quick example that might be confusing after that is this. X plus 4 is, where's the absolute value of x plus 4 equal to 7? So solving that. Now, because this is addition, you want to be careful, because x plus 4 doesn't give you the distance between x and 4. It needs to be subtraction. So one way to look at it would be x minus negative 4. Remember, subtracting a negative number is like addition. And then we can kind of use our distance idea. So we're looking for the distance between x and negative 4 to be 7. Which means if I had the number negative 4, I would want the number that is 7 above that, which is 3, and the number that is 7 below that, which is negative 11. So you're saying, oh geez, now I got to keep track of negative signs, turning the positive into subtraction, all that stuff. Well, not really, because you can use that second idea that I was talking about as well, which is to say that either x plus 4 is equal to 7, which is okay, because the absolute value of 7 is 7, or x plus 4 is equal to negative 7, in which case the absolute value of that is also 7. So subtracting 4 from both sides, this will give me 3. Subtracting 4 from both sides, this will give me negative 11. You'll get the same answer either way. So why don't you try one, and maybe we'll try to make this one. No, we won't make it too hard. So we'll say x minus 6 is equal to 5. Okay? And we'll see how you do with that. I think you'll be fine. Alright, so apply appropriate strategies to estimate quantities in real situations. Huge topic, but I feel like the most common would be solving things with ratios and proportions and stuff along that line. So let me just quickly jot down a problem for us to solve. Alright, so we have the ratio of bunnies to cats is 2 to 3 at a local pet store. If there are 24 bunnies, then how many cats are there? So what's really important, the only thing that's truly important with setting up a proportion. By the way, a proportion is an equation of two equal ratios. Okay, so I would need two different ratios. And you say, well, what is a ratio? A ratio is a comparison of two numbers. So when you see up here a ratio written like this, the ratio of bunnies to cats is 2 to 3, is what that means. So that means that this ratio, 2 to 3, and I'm not just doing this for you, I do this myself all the time, off to the side. That means that my numerator is counting kind of the number of bunnies, and my denominator is measuring cats. Okay? And you say, well, then Chaz, why didn't you do cats over bunnies? Why did you do bunnies over cats? Well, I just wanted to. It's just the order that it's in. The order that you set up that ratio is unimportant. And I tell people this all the time. The only thing that is important is when you go to write your second ratio. And it has to be exactly like the first one. So what I mean by that is I set this ratio 2 to 3. You could be careless about it. It could be 2 over 3, 3 over 2. Doesn't matter. But if my numerator is 2, it means that I'm counting the number of bunnies. Okay? Which means when I write my second ratio, that numerator must also be bunnies, and they tell me that there are 24 of them. Okay? My denominator here is cats. In my ratio, I have 3 cats. Here, I don't know how many cats I have, so that's x. So how you set up your first ratio doesn't matter. The second ratio must compare the same things. Okay, and I can just cross multiply there. I get 2 times x is 2x is equal to, and I get 24 times 3 is 72. Great looking 72. Oh, fantastic. Probably the best looking 72 I've ever drawn in my career. Okay, and divided by 2, I get x equals 36, and we don't want to forget our units, and our units are cats. So there are 36 cats there. Okay, so let me come up with one question that I'm going to leave you with. It's going to be a little bit of a challenge. All right, so this is the question I'm going to leave you with. If I'm going to keep the same ratio as above, so there's still a ratio of 2 to 3 bunnies to cats. So it says if there are 35 total bunnies and cats, so both animals combined, how many bunnies are there? So out of that 35, how many of them are bunnies? Okay. Now the setup is not going to be exactly like the one that I showed you, which means that you're not going to be comparing bunnies and cats because I didn't give you that information. I gave you like a total amount. So you're going to be very careful how you're setting up a ratio, but make sure that whatever ratio you choose, that second one is going to be set up identically as far as what you are comparing. Okay, so good luck with that. It's a little bit harder. Actually, it's a lot harder than the first one, but I'd like to see how you do. I'll bet you're going to be just fine. I apologize for the length of this video. I'll try to keep them rather short, but I don't know. I'll find a way to blame Mark so you guys don't hate me. Have a wonderful time, and I will see you guys later. Thank you.